Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazrul Izwan. We are from Group 3 and today we will be presenting our project for network analysis and design.
Okay, first of all, let me introduce our group members. First is Muhammad Nazrul Izwan bin Maisa, Kirubashini anak perempuan Serbakuma, Siti Aisyah binti Al-Zaidi Herman, Hanis Syahada binti Harun, Satesh Rao anak lelaki Kumar Rao, and myself Ahmad Zikri bin Azizi, Muhammad Akmal Harith bin Mat Zahir, Raja Muhammad Hadi bin Raja Ahmad Qari, Nik Muhammad Haikal bin Fairuz Sidi.
Okay, first of all, we start with the background of the company that we have choose. We decide to pick Sekolah Menengah Imtiaz Ulul Albab Melaka, or what people usually call it as just Imtiaz. So the school is located in Masjid Tanah, Melaka, and the nature of the business for the organisation is business education. So there are three main problems with the current network in the school. Okay, first, the school current network have a limited internet coverage. The current network unable to cover the wide range of the area of the school. Next is the inconsistent in bandwidth and connectivity. After we have done our interview with the school representative, we know that some of the students complain about some of them are unable to get the internet, or the speed of the internet is slow. Next, regarding the network security, we intend to provide or upgrade a more secure network for the school.
Okay, now I want to explain about scope of the project. So we have three scopes, which is location, user and administration. So the first is location, is to upgrade network infrastructure by installing more access points, upgrading equipment and implementing redundancy and failover mechanism. The second scope is user, is to consult stakeholder for network needs, add access point, upgrade hardware and secure with user authentication and access control. And the last scope is administration. The administration is to assess the network, create management documentation and establish incident response and disaster recovery protocol. Okay, now we continue with objective. The first objective is to extend stable internet to all areas of Sekolah Menengah Imtiaz Ulul Albab. The second objective is upgrade infrastructure. Third is implement security measures. Fourth is enhance performance with redundancy, and the last one is design for future scalability.
So I'll be presenting the criteria of dynamic evaluation for a network project. So the aim over here is to actually minimize the network deployment and also the operational cost. So let's jump into the technology evaluation. Over here we could see there's actually 5 composite flows. So this different type of composite flow, it represents the type of network within our LAN. So as we can look at here, there are 4 metrics over here. Area. This is actually to show all these flow are within the LAN. And second one is capacity, which is also known as SDR. This indicates the maximum data rate for each flow in megabyte per second. And the third one is maximum capacity needed, calculated by dividing the SDR by 0.6. So this representing the peak bandwidth requirement. And the last one is user. So the number of user for each segment that supports. So as we look at here, the detailed breakdown, we can look at the CF1. So it is stated over here that the capacity for CF1 is 70 megabyte per second, and this is the maximum data rate for the segment. And the second one is the maximum capacity needed, 116.67 megabyte per second, and this is calculated as 70 divided by 0.6, and this represents the peak of bandwidth needed. And the last one is the user. So there's 15 user, and this number actually shows that the number of users that supports by the segment. And the same method we'll be using for the CF2 until CF5. And let's jump into the backbone flow. So the backbone flow, which is also abbreviated as DB, this represents the wide area network component, and this is crucial for our network capacity. So over here, we're following the same method as CF. It will also be divided, it will be calculated as using the capacity will be calculated by dividing it by 0.6, and we'll be getting the maximum capacity needed as well. And over here, the user is actually 10 users. So now let's jump into sizing network. So over here in this section, sizing the network, we can see that this network layout is actually included key components like office, headmaster room, server room, and various classroom. So each area is actually connected through different network flows and corresponding to the composite flow as we discussed. So the diagram detail of the type of connection and the capacity and associated metrics that I can see for each segment. In summary, we assess that composite flow within the LAN and analyze the backbone flow for one capacity is to ensure that each segment supports the expected number of user while minimizing the cost.
Assalamualaikum. My name is Raja Muhammad Hadi bin Raja Ahmad Kori. Today, I will be presenting the interconnection mechanism on the network at Sekolah Menengah Imtiaz Hulu Albab Melaka. Our network is crucial for facilitating communication, resource sharing and data management across various areas of the school. It supports daily operation, enhance educational activities and ensure seamless connectivity between different departments and Now let's start with the network topology. Our network is structured into 5 key areas. Area 1, this area connect the school network to the Ethernet tools and ISP. Area 2, serving as the central hub, it connect all the areas. Area 3, house administrative office. Area 4, used by the teaching staff. Area 5, include dormitories and classrooms. The server room in area 2 is the backbone of our network. All data traffic from various areas converges here before being routed to their destination or to the internet. Next, we look at the concentration of flow in each area. Concentration of flow refers to the ratio of incoming and outgoing data traffic related to the pathway connected to the server room. This concept is essential for understanding the data log. Each area handles an impact on network performance. Area 1, 1-to-1 ratio indicate a balanced connection with equal incoming and outgoing data. Area 2, 3-to-1 ratio show a higher concentration of traffic, highlighting the server room critical role in managing the network data flow. Area 3, 2-to-1 ratio suggests moderate data traffic with more incoming than outgoing data. Area 4, 1-to-1 ratio indicate a balanced flow with no redundancy. Area 5, 2-to-1 ratio show moderate traffic with the dorm room and classroom having a higher volume of incoming data. These ratios are crucial for understanding the data flow and potential bottleneck within the network. Now, let's discuss the degree of hierarchy and redundancy. The degree of hierarchy and redundancy are important for understanding the network structure and its fault-tolerant capability. For Area 1 and Area 4, no hierarchy and no alternate path, indicating single point of failure. Area 2, medium hierarchy with 1 or 2 alternate paths, providing some level of fault tolerance. Area 3 and Area 5, low hierarchy with 1 alternate path, offering limited redundancy. Redundancy ensures that if one path fails, there are alternate routes for data to travel, enhancing the network reliability. Next, we move to the next slide. Added router and switches. To improve the network connectivity and redundancy, additional routers and switches has been implemented. Area 2, the server room. The addition of multiple routers and switches enhances the network core infrastructure, ensuring that the data can be efficiently routed and switched between different segments of the network. This also provides alternate pathway in case of a device failure. Area 3, office and headmaster room. An additional switch ensure that even if one pathway fails, another switch can handle the traffic, maintaining network connectivity. Lastly, for Area 5, dorm room and class, additional routers and switches may ensure that the high concentration of traffic can be managed efficiently and that there is a backup path available to handle any failure. These additional routers and switches play a crucial role in maintaining the network reliability and performance by providing multiple pathways for data to travel, thus preventing a single point of failure and ensuring continuous connectivity. In conclusion, the interconnection mechanism of Sekolah Menengah Imtiaz Hulu Albab Melaka network is vital for its functionality and reliability. The well-structured topology, appropriate concentration of flow, degree of hierarchy, and redundancy all contribute to a robust network. Understanding the role of routers, switches, and firewalls further enhance our grasp of how the network supports the school operation.
So, for Network Management System (NMS), what is Network Management System? It is a set of tools and applications designed to manage, monitor, and maintain computer networks. It gives network administrators with the ability to keep track of network performance and ensuring the network is available at all times. There are a few reasons why NMS is implemented into any networks, such as network monitoring, configuration management, fault management, and performance management. Now, as you can see in our diagrams, we have implemented a few network management components, like here, 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 and here. As you can see, most of them are right before the routers of each LANs or each area. This is to ensure the monitoring system can track of the outgoing and incoming traffic. As you can see here, when the traffic goes in, it has to go through the monitoring system first, and when it goes out, it has to go through the monitoring system, and all of it will be sent to the central monitoring management system. For security mechanism, we implemented a few, such as firewall, access control, DMZ, and user authentication. So what is a firewall? Firewall is designed to monitor and control the network traffic based on predetermined security rules. It acts as a barrier between trusted internal network and external networks, such as the internet. Firewalls are important components of network security. It allows for protection against unauthorized access, cyber threats, and malicious attacks. Second, an access control list. So an access control list is a set of rules used to control network traffic and enforce security policies by determining which packets are allowed or denied access to specific network resources. They are usually implemented on network devices such as routers and switches. Thirdly, we have DMZ. So DMZ is a physical or logical subnetwork that contains and exposes an organization's external-facing services such as a web server to an untrusted network, typically the internet. The main purpose of a DMZ is to add an extra layer of security to an organization's local network. It allows external users to access specific service while preventing access to the internal network. Lastly, we have user authentication. So it is a process of verifying the identity of a user who is attempting to access a system network application. This ensures that only authorized user can gain access to protected resources, thereby maintaining security and preventing unauthorized access. So with user authentication, the legitimate users can still access the network from outside if they have the correct credentials.
This figure shows the wiring scheme for this company, which is centralized wiring scheme. In the server room, PP, patch panel, and POP, point of presence, which is the entry point of data to building, are located here. All the patch panel, fiber monitoring, and testing equipments can be operated from the central point, which is in the server room. Centralized wiring scheme is more efficient because electricity can be generated at lower cost per unit when it is produced in large quantities at central point. It is also easier to maintain and repair.
Next is for the addressing strategies. For the workshop cloud, the number of hosts is 1, server is 10, office, the number of hosts is 35, in headmaster office, the number of hosts is 15, in dorm 900, in staff room is 140, and in class is 900 hosts. Next is the major network address that we use is 172.16.0.0 side 16. This is the VLCM table. Here is all the IP address and usable addresses for each subnet, which is dorm, class, staff room, office, headmaster office, server, and cloud.
And the routing strategy, this picture have shown the 5 areas with the concentration of paths which we need to identify the degree of hierarchy for our routing. This table shows to identify the degree of hierarchy and redundancy based on our concentration of paths. So first, for area 1, with concentration 1, the degree of hierarchy is none and the number of paths is no alternate path. For area 2, the concentration is 3, with the degree of hierarchy medium, the number of paths is 1 or 2 alternates with unequal. For area 3, concentration with 2, the degree of hierarchy is low, with number of paths is 1 alternate and unequal. For area 4, the concentration is 1, with degree of hierarchy none, the number of paths is no alternate path. For location, for area 5, the concentration is 2, with degree of hierarchy is low and the number of paths is 1 alternate and unequal. For selecting the appropriate routing protocols in the design, this diagram shows the chosen routing protocol that is suitable for our design. This routing protocol that is suitable for this network design is BGP v4.
In conclusion, the network design project for Sekolah Menengah Imtiaz Ulul Albab Melaka has successfully achieved its goals of creating a robust and efficient network infrastructure tailored to the specific needs of a modern educational institution. The implemented network ensures scalability to accommodate future growth, robust security measures to protect sensitive data, high reliability and performance to support daily operations, seamless integration of devices and systems for enhanced accessibility, and a cost-effective balance of wired and wireless solutions. This project exemplifies our commitment to providing a reliable and secure environment that supports the educational mission of Sekolah Menengah Imtiaz Ulur Albab Melaka, preparing the students, teachers and staff for success in a connected world.